companion to Betty's last night, basic data management in SAS. So Lauren, take it away.
Thanks, Samantha. All right, I'm going to share my screen. Okay. Thank you, everyone, for coming. I can second Samantha's sentiment. We're really happy that you've been here and joining us this week for whatever sessions you've attended, and we hope that you have gained some valuable information and learned something. So today, I will be giving the final presentation of CU Data Week 2024, covering basic statistics in SAS. So a quick agenda. I'm going to briefly give an overview of SAS. And like Samantha mentioned, yesterday my colleague Betty gave a presentation titled Basic Data Management in SAS. And I would encourage you, if you are a new SAS user, to head on over to her learning materials and watch the recording once it's posted to our website, because she does dive into how to interact with the various SAS environments, how to create new variables, do various data management tasks, and then have a completed, ready to analyze data set. So I will be using one of the data sets that she generated in her presentation last night as our analytic data set in some of our research questions today. So we will be looking at some descriptive statistics, completing tests like the chi-square test, 2 sample t-tests, some paired tests, non-parametric tests. I'll give an example of a simple linear regression, and then we'll look at a couple of different plotting options like a histogram. Before I move over into the SAS environment, I did just want to provide a couple of links that I find very valuable as a SAS programmer. The first link here is SAS Studio. So that is the free online cloud-based SAS environment that you can sign up for and use. There are some limitations to it, but if you're a new SAS user, there are plenty of opportunities for you to play around and practice coding there. The second link is to SAS documentation, which is essentially the online manual for everything that you need to use in SAS. So every command, all of the syntax options are provided there, so you can search for whatever test you might be wanting to complete, and all of the information about how to do that is provided online. And finally, it's the SAS communities link, and I really like SAS communities because it's an online forum of everywhere from novice to extremely advanced SAS programmers. You can find questions that people have posted for a really long time over the course of the SAS community's history, and find maybe answers to questions that you are also having with your SAS programming needs. If there is not already a forum thread there of a question that is relating to what you need help with, you can post a question and get answers within a couple of hours to a day or two. So it's a really great resource. Great, so I'm going to switch on over now to my SAS environment. And as I said, Betty's presentation yesterday was basic data management in SAS. And so she worked in the SAS environment, the SAS On Demand Online. Today, I'm going to work in the alternative environment, which is the windowing environment. This is a license-based option. So here I work at the university. The university has a license with SAS, and so it's a desktop-based version of SAS, which does not require internet in order to complete and submit code. I just wanted to provide an opportunity for you to be able to see how SAS works in different environments. Similarly to the windowing or the SAS on-demand version online, we have some different windows here that I'll give you a quick overview of. So the main window here is our script or our SAS program. So this is where we will be typing throughout creating our code. We also have a log, and so this is going to be a running log of all of the code that we are submitting in our session. And if there's some sort of error or warning, it will show up there. It gives us some overview about how many observations and variables are in the data sets that we are manipulating and running. So it's really important to have the log up. I like to make my log up here at the top. So every time I'm submitting code in my script file, I can see the newest log message right in the same window, and I'm not having to switch back and forth between tabs. Over on the left, we have our Explorer. And the Explorer is similar to your File Explorer on your local computer or whatever machine you're on. We have a main libraries icon, and so I'm going to click into that, and we're going to see some active libraries. Working within SAS, we have to read and write our data to SAS libraries, which are going to be linked to some location on our computer. So right now, I haven't set up a working directory at all. So these are just the automatic libraries that we have access to when we start a new SAS session. The ones I'll point out are the work library, which is a temporary library that I like to read and write data to while I'm testing code out, checking different things are working, because once I close out of this SAS session, everything that has been stored in the work library will be deleted. So it's not taking up any space on my computer. There's also this SAS help library, which has a whole host of pre-made data sets that you have access to that you can use to test code and play around. So I will also be using a couple of these data sets today just to get you familiar with those. So from there, I'm actually going to move on to my actual code. So the first thing that we always need to do if we're going to be working with data that we have created or received in our research pipeline is to set up a working directory so that SAS can communicate with that information. So like I explained before, libraries are folders within SAS where our SAS data sets are stored. And so I have provided code for both the SAS on-demand environment as well as the windowing environment. So if you've pulled this SAS program up in the windowing environment, numbers 1 and 2 will relate to how you're going to be setting up your session. We're going to define a path route, which is basically telling where is our parent folder that we want to be doing everything related to this project. So if you go to your home folder and you right click and go to properties, it's going to give you this home / and then this user ID. And that is unique to the email that you specified when you set up your SAS on-demand account. And then you can create folders within your environment. And so I had just created one called CU Data Week 2024. And that's where I then wanted to do everything relating to the week of classes this week. So once you've created this direction of where is my parent folder that I want to create my libraries, you can then create as many libraries as you want. So we always start this library statement with the lib name option, and then you're going to create a name for that library. There are a couple naming rules that you have to follow. It cannot be longer than 8 characters, and there can't be special characters or spaces in there, so you can't have like an exclamation mark or anything. So I'm going to just create one called data raw, which would be where I might read in the raw data from an Excel file. And so then in quotation marks, you're going to give this path route. So the parent file path that you defined right up here, and then followed by the name of the folder that you would have nested within your CU Data Week parent folder. And then I want to do the same thing and create a data clean folder or library, and then specify where that folder is located. And if you want full details on how to do that, again, I would go to Betty's materials in the basic data management for SAS presentation. So today I'm going to be working in the windowing environment. So it's the same structure, just slightly different in how we're communicating with our local drive rather than files being housed on the cloud within SAS. So I'm going to define my root folder. And so I've created this CU Data Week _ 2024 folder within my university provided OneDrive account. So you can see the full file path of where I've created it. It's in my OneDrive. I have a projects folder. In that projects folder, I have my work folder. And then this is part of me being on a committee. And then this year's Data Week. So it's a long file path. but we're basically creating a shortcut going forward. So then I'll have my lib name statement again, and I have a data raw folder within my CU Data Week 2024 folder, and I want to create my SAS library of the same name there. And similarly, I'll do the same thing with a data clean folder. So I'm going to submit this code, and I'll highlight the whole row and come up to this running silhouette here to submit that code. And if we look in the log, we can see that there are no warnings or errors. Those show up as either green or red text. So now I'm going to submit the next two lines where I'm defining my libraries. And I just want to point out that over here right now, we don't have any libraries called data raw or data clean. So let's see what happens when I submit. Great. I have messages up here that say that my lib reference called data raw was successfully assigned. Similarly, my lib ref called data clean was successfully assigned. And now over here in my Explorer, I have access to my data clean and data raw libraries. So just to sum it all up, we're telling SAS how we want to communicate with the data sets and data files that we have either saved in the cloud in the on-demand environment or locally on our machine in the windowing environment. Alrighty, so again, I did already cover this work library. That is our temporary library to work in, and this SAS help library, which has a bunch of free usable data sets of various structures to be able to interact with. So in my data clean library, I have a already completed birth weight clean data set. So that's also in the OneDrive folder that we provided for today's session. And let's just open it up to get a quick view of what's going on here. So on the left hand side, we have the number of the observation that each row relates to. And then across the top, we have all of the variables and their respective names. So I like to just look at what's going on with my data set before I even dive into working with code. So we can see there's a lot of variables in here. We have a variety of different value types. And so we're going to summarize that here. So the first thing that I do after I've opened the physical data set within SAS is I'll run a proc contents. And this is going to tell me what is actually in my data set. And I will note that within SAS, there's two main categories of ways that you will be interacting with your data. One is a proc, which is an abbreviation for procedure. And so that is a way that you're going to be summarizing the data that you have. And then the other option is called a data step. And data is where you're manipulating your information. You might be renaming a variable, creating a new variable off of values of other variables. And so that is where you would be processing your data before you get to the point of running statistics. So we're running a proc contents, which by its name sounds like we'll be learning what the contents of this data set are. And I also will just point out that we are working with data in our data clean library. And so you specify that before the period, and then after the period is the name of the SAS data set that we are wanting to look at. So I'm going to submit this code, and we'll see what we have. So here we have the first part of the table is the various metadata regarding what's going on in our data set. We have the data set name, what library it is in, when it was created, when it was last modified, the number of observations and variables. And then if we keep scrolling down, we're going to see other things like where is this file stored locally? What type of machine is it on? And then more importantly, for actually working with the data, we have a table of all the variables, the variable types, and the variable lengths that are in that data set. So we can see that there are a total of 20 variables. We have all of the names in this variable column, and then we have the type. So in SAS, there are only two types of data, which is different from other programming languages. You might be familiar with R, in which case you have many types of data formats. You can have things like factors, strings, etc. In SAS, there are only two. One is numeric and the other is character. And so we can see here in this column that we have mostly numeric variables, and then we have a couple here that are character. And lastly, we have this length column. So LEN is just an abbreviation for length. And it will tell us how long in bytes our data types are within that variable. Numerics default to 8 bytes. And then the character length is going to represent the length of characters in a string of the longest value in that variable. So here for race, we see that the longest race category type is going to be 8 characters long. Whereas if we come down to BMI cat, which is the categorical version of BMI, our length is 14 characters. And so characters can be any combination of alphabetic characters, numeric, special characters, and spaces. Okay. And then just for fun, if you want to start playing around with different options, this var num argument within the proc contents is telling SAS that I want the variables listed in the order they appear in my original data set. If I didn't have var num there, they would appear in alphabetical order. So I prefer to have them in the order that they came in the original data set, but other people have other preferences. So that's one option there. I'll just stop briefly to see if there's any questions in the chat that people have about the basic environment of SAS. All right, if no questions, I'll continue on. So looking at basic statistics in SAS is not a one-size-fits-all. So there are many different procedures that we can use to generate the same and or similar statistics of various types. So we have of some of the procs, proc means, which sounds self-explanatory. We're going to get some numeric summaries of numeric variables, proc univariate, proc tabulate, which generates tables, proc freq, which is for generating frequencies, and proc report. So I'm going to show you a few of these today. Everybody who has been working with SAS for a decent amount of time has their preference of which procedures they prefer. So as you continue to code, you'll decide which ones you like and which ones you're less familiar with and you don't really want to work with as often. So I think proc tabulate is a very valuable procedure because you can get a nice looking table to summarize your statistics with very few lines of code. So we're first going to specify proc tabulate. So now we have within this proc, there are a bunch of different options that we can specify. We are still working with the data set birth weight clean in our data clean library. And so now a new line of code that we have is this class statement. And class is an abbreviation for classification. So this should indicate to SAS that I want to define the variables after class as categorical variables. So my variable called mom smoke is a categorical variable. It's a yes/no variable. If we look at the type, we see here that mom smoke is numeric. But that doesn't mean I want to look at the values numerically. So we have dummy coding here where a 0 means no and a 1 means yes. But it wouldn't make sense to take the mean of those values because that doesn't mean anything. We want to understand how many people in terms of count fall into the yes category and how many fall into the no. So that's why we're specifying them in this class statement. The var statement then is the list of numeric variables. So these are variable types that actually are numbers of importance. Here we're going to be looking at the weight of a baby, but you could think of this as any numeric variable. It could be some sort of lab value on a blood measurement. It could be height. If you're not working with health data, it could be something like distance, whatever it might be. So we want to summarize it as a continuous variable. So once we've classified what our variable types are, we're then going to define our table. So any of the variables that you have listed before the comma will be your rows in the table. And then the variables listed after this comma are going to be your columns. And then we'll put an asterisk, to define what statistics we want in the table. So because we're looking at weight by mom's smoking status, I want that summarized as both mean and standard deviation. And then I'm going to put some special formatting on there just so that it looks prettier when I'm looking at the table. And I want my numbers to have one decimal place after one number after the decimal. So we're not getting these really long numbers where we don't need that amount of precision. And then after this forward slash, I'm just specifying no cell merge to make sure that there's not any weird merging that happens once I submit this code. So I'm going to run it and we will see our results. So I'm going to have things side by side just so I can explain. But we have this table and it was really easy for us to specify it. And we have now two sets of statistics by mom smoking status. So we have two columns for no smokers, the 0 group, and we have the mean weight and standard deviation of that weight for the non-smokers. And we also have the mean and standard deviation weight for smoking moms. And so we can just quickly see here that there may or may not be a difference by smoking status for the birth weight of their baby. So what if I have two variables that are categories, not one numeric continuous type in one category? We can also use proctabulate, but we're going to change things around a little bit. In our class statement, we're going to specify that both the variables we're summarizing are categorical. And then in the table, we no longer want mean and standard deviation to summarize our information. We would like to have an N or a count and the column percent of that count by our mom's smoking status. Again, I'm going to ask for, well, maybe here I'll choose to have 2 decimal places. And so let's look at this table. So here we are. We can see that my format to have 2 decimal places worked. We have that here now. And again, we have our columns by the mom's smoking status, no and yes. And then in education level, we now have 4 categories that we wanted to summarize within. And the cool thing about all of the options in SAS is we can specify a variety of different statistics. So I did not have to choose column percent, where if we would rather have an interpretation of looking at the distribution of smokers within an education level, I could have chosen to done a row percent, where I'm looking at what proportion of non-smokers, what proportion of moms with education level 3 are non-smokers, and what proportion of the level 3 education mothers are smokers. So depending on what your research question is or what types of interpretations you're wanting to make, you will just choose what statistics you want to generate based on whether it's appropriate for the variable type and then what your questions are. So here I would look at this and think, among non-smokers, 33.3% have education level 0, about 25% have education level 1, etc. And then within smoking moms, 45.4% have education level of 0, etc. So we're interpreting within the column. But you could change that to a row percent, as I said. All right. Any questions about proctabulate? I don't see anything in the chat, so I'm going to just continue on. So now let's dive into some actual research questions that you could translate to your practice. So first I want to ask, is maternal smoking associated with low birth weight? And if we look at our data, we can see that low birth weight over here is a 0-1 variable. So I want to treat this as a yes, no, or a categorical variable. I don't want to consider it a numeric like I might have with weight, which was weight in grams. So this is a unique test because I'm going to be looking at a categorical variable compared to a categorical variable. So let's just set up a quick table to look at the distributions. And so I have a yes, no against a yes, no. So this is just a quick and dirty way to look at it. Another way that we could look at the same count and percent distribution is by running a different proc called proc freq, which I stated means proc frequency. And so we're going to do a cross tabulation of these two categorical variables. So we have the first variable, which will be our rows, and then an asterisk, and then the next variable, which will be our columns. And so I will submit this code. And now we have basically the same table. We could see here that if you were a 0 smoke, 0 low birth weight, it was 41,333 people. That matches here because it's the same test, is just displayed slightly differently. And proc-freq, it will automatically give you 4 different numerical values in summary. We first have the N, or frequency. We then have the percent out of the total population, which here is 50,000 people. Next is the row percent. So looking at the distribution within a row category. So 87.6% of people who had a low birth weight baby were non-smokers. And then we have column percent, which is looking at within a column, 95.1% of non-smokers had a low birth weight baby. So now I want to do my actual hypothesis test, testing, are these two variables associated? So all I'm going to do is just tack on this new argument to the same proc-freq I just ran above. And this is the option for running a Pearson's chi-square test. So I will submit that. So here, once again, we get that same frequency procedure, but we now have new statistical results added on. There are a lot of results here, which many of them are beyond the scope of today's seminar. But if you want to learn about what each of them means, I would definitely recommend looking at the SAS documentation or continuing on in more advanced statistical coursework. But the main test that we're interested here is this chi-square test that we see in the statistics column. We have our degrees of freedom of 1, and then we have our statistic value, and then this prob column is the p-value, so prob for probability, and in SAS, all of our p-values are displayed as prob. So if we're looking here, we have a p-value of less than 0.0001. So we could say that low birth weight and maternal smoking are significantly associated. I also want to note that SAS will automatically give you this Fisher's exact test table, which is not important for us here because we have a huge sample size of 50,000 individuals. But if you had a very small sample size where you would have a count of 5 or less of individuals in one or more of these cells in a cross tabulation, it would be statistically appropriate to look at the Fisher's exact test, in which you would look at this two-sided p-value and its result down here. But it's not something I would need to consider with the sample size of this birth weight data set. Okay, so now I have a new research question where I want to look at, does infant birth weight differ by maternal smoking? So now I'm looking at birth weight in terms of the continuous weight in grams. And so we no longer have two variables of categorical type. We still have maternal smoking, which is a categorical variable, but now birth weight is continuous. So this would mean that I would probably first look at a 2-sample t-test. So I will summarize our birth weight by mom smoking status, which, if you'll recall, we did above already. But we want to now look at our hypothesis test. So we have a new proc called proc t-test. And so this will be the main procedure that we use to do a variety of t-tests. So again, we're classifying mom smoke as a categorical variable, and then var, which means our weight, or sorry, our variable is a numeric continuous type variable. So I'm going to submit the t-test. And we will look at our results. So the first table out of the t-test procedure gives our summary statistics, the count, mean, standard deviation, min, and max by our mom smoking groups here, the 0 and 1 for no and yes. And then we're getting some new rows that we didn't have in our previous summary tables. And these are the difference between the means of the mom smoking group. So we have differences calculated already for us. I will note that the t-test procedure is assuming normality of the distribution of our weight values as well as equal variance in those values between the two groups. So we could look at this equality of variances table to see if we are meeting that expectation, that we can either accept or reject the hypothesis that they do have equal variances. And depending on that, we have two different methods for the t-test, and the Satterth weight is generally more conservative. So we would look at this method variances table to get our interpretation. And so if we look here, we would say that we have a statistically significant p-value for our hypothesis test. We also get some figures to go along with our t-test, which are again valuable in learning about what is in your data. We have histograms split by our categorical variable. So this first panel is for mom smoke of 0, and then the second panel is for mom smoke 1. And so we have a pretty decent, normally distributed distribution by our groups. The blue line is a normal distribution, and then this orange-red line is it's a kernel curve, so it's fitted to our data, so we can compare it against this normal curve, and it's looking pretty good in comparison. We also get these box plots here on the bottom by group. And then we also have QQ plots, which is a dot for each observation in our data. And to assume that it is normally distributed, we would look at all the dots being ideally along this 45-degree angle line. We have a little bit of deviation down here. So that might indicate to us that a parametric or normal test might not be the best for this data. So let's say we did not want to accept a parametric test for our data. Let's look at a non-parametric option. So again, we're looking at, does infant birth weight differ by maternal smoking status? And this is going to be a test where we're not going to assume normality of our weight values. And so this test is called the Mann-Whitney U test, or also called the Wilcoxon rank sum test. And that is going to be in a new procedure. And this procedure is called the N-par one-way. And then we're going to specify at the end of this proc statement, the Wilcoxon option. So that is going to be telling SAS that we want to look at the Wilcoxon rank sum test in this procedure. Just as we had before, it's the class statement for our categorical variable and the var for our numeric variable. So I'm going to run. And we have our output for this test. So we have the first table, which is the generation of how SAS is ranking these values. And then the second table is the one where we're going to look at what is our interpretation for this hypothesis test. And SAS automatically gives you results for different statistical tests, and one may be more appropriate than the other depending on your data. So we have a z-score based test, and then we have the t-approximation based test. So luckily, in both instances, we see that our interpretation of a statistically significant difference by maternal smoking is congruent across both of these statistical tests. And then we also get the Kruskal-Wallis test, which would be if we had more than 2 categories of mom smoking status. And finally, we get this figure, which is the ranking of these values stratified by our mother smoking status. And I do want to point out that when we're looking at box plots of any type across SAS output, the line across the box is the median value, and then this diamond or square is the mean value. So that is consistent whether you're generating just a simple box plot or it's coming out of these other procedure types. And then you'll also see overlaid here are the statistical significance results for these 2 tests. Okay, so moving on to our next scenario would be, what if we have multiple measurements taken on the same person, or taken on some sort of the same unit? So maybe this is on the same cell, if you're looking at cellular biology questions, on the same individual, any type of animal, etc. I am going to need to make different considerations because we no longer have independent measurements. We have multiple measurements on the same unit. So we can't treat them the same way that we would if we had independent observations. So I'm going to switch over to a SAS help data set just so you can see how we're working with different data sets in SAS. And so I'm going to come to the SAS help, and I want to be working with our CARS data set now. So I'm just going to scroll and find that data set, and we'll take a look at it. So here we have a singular car make and model and type in one row, but along the top, you can see that we have several measurements on each individual type car. And we have 2 miles per gallon measurements. We have one that is the city driving miles per gallon, and we have another that is the highway miles per gallon. So maybe we want to understand, are these 2 values on a single car statistically different? Or excuse me, on average, is there a statistically significant difference between the miles per gallon highway and the miles per gallon city? So we can no longer treat each car and its measurement as independent because we're taking 2 values from the same car. So we're now going to switch over to a paired t-test scenario. So we know that we have a measurement for city driving and a measurement for highway driving on the same car. And so we're going to test, is there a significant difference in those 2 values? We're still using a proc t-test, but the slight difference, we're no longer doing a class and var statement within proc t-test. We're specifying a paired statement, telling SAS, we need you to know that these 2 values are coming off of the same unit. So I'll submit that. And I will get new results, which, if you remember, now look different from our regular t-test procedure. So we're going to get our summary measure across all the observations. We have 428 cars that we were looking at. And under this mean, this is now telling us what is the mean difference between highway mileage or miles per gallon and city miles per gallon. So we can see that there's a mean difference of negative 6.78. And so then we have the confidence limits, our standard deviation. And then down here is our statistically significant result for looking at, is there a significant difference between the city miles per gallon and the highway miles per gallon? We then again have some visualization of the data. So we have a histogram with our normal curve overlaid, and then our kernel curve that's fitted with our actual data. We can see that this curve is not well represented compared to our blue ideal normal curve. So like I said before, these types of visualizations may indicate to us that this is not the appropriate test for our data. So then there's a couple other plots. This one is not easy to look at nor to interpret. We have an agreement plot. So this line up the middle, it would be if there was no difference between the city miles per gallon and the highway miles per gallon. All of our dots, for the most part, are seated above that line. So that is a visual indicator that we may have a difference between those 2 values. And then again, we have a QQ plot, or also called quantile plot here. So again, a t-test assumes normality of our data. So what if, based on the visualizations here, we can't assume normality of our data? What are our other options? So our other options would be a Wilcoxon signed rank test, which is different from the Wilcoxon rank sum test. They sound really similar. It's confusing. I'm still confused why it's named that, but anyways, we're still asking the same question. Is there a significant difference in cars miles per gallon in city driving compared to miles per gallon highway driving? And we are not going to be assuming normality in this case. We don't have the option to just say paired like we did in the t-test. So we're actually going to create our own difference variable for each of the cars and then use that as our variable of interest. And so that's going to be within a data step, which again is the type of chunk of code in SAS that's telling the data set, how do I want to manipulate my variables? Do I need to create a new one? Am I renaming an old one? Do I want to convert the data type, etc.? So we're taking our cars data set from the SAS help library. We're going to create this new data set called analysis. And because I don't have a library listed before that, it's automatically going to write to that temporary library called the work library. And I'm going to create this new variable called diff underscore MPG. And I'm going to take the difference of the city MPG, or take the difference from city MPG by highway MPG. And so this is just a basic arithmetic equation, and it's going to occur for each line in our data set or each row. So for each unit, which is a car. So once I have that new variable created, that is now going to be the one that I'm analyzing. And I'm going to use this proc univariate option, which is a new procedure again, but you'll see we're getting really similar statistics. Oops. I didn't run my data step. So actually, this is a good lesson. You can see here that I have a note saying the SAS system stopped processing because of errors, and I have an error saying that my work analysis data does not exist. That's because I did not submit the code above, and it couldn't run anything because it didn't have data. So now we'll get results. Alrighty. So we have our summary table once again, and here we're looking at this diff MPG variable we just created. We have the count, we have the mean, standard deviation, etc. We're going to scroll down to look at the tests for location. And specifically when we have correlated data from the same unit, we're going to look at the signed rank row, which is that Wilcoxon signed rank test. So we have the test statistic, and then based on that, the significance of that statistic. And once again, all of our examples are statistically significant, so we could interpret that we do have a significant difference between the miles per gallon city driving compared to miles per gallon highway driving. You also will get a statistical measure table that shows you comparisons of the mean, median, and mode of that variable, a description of the quantile values and the percentiles, which may be of interest, and then extreme observations. And I do find the extreme observations table very helpful when I'm working with variables that shouldn't have a negative value, for example, or shouldn't be outside the limits of 1 to 10, and then I have a value of 300. That's a good indication that there's something weird going on in the data, and I need to investigate that before I continue performing any statistical testing. Okay, so our last scenario today is looking at if there is a significant linear relationship between weight and height amongst children in a classroom. And so this is going to be fitting a simple linear regression to these variables of this data set. I'm going to be using a different data set from the SAS help library called class, which we'll take a look at. So we have 19 observations, so definitely smaller in comparison to our previous data sets, and only a few columns. I have name, sex, age, and then I have height and weight. So these are the two variables that we're interested in. Is there a linear relationship between these two continuous variables? And I'm going to assume that weight is measured in pounds and that height is measured in inches based on the age of these students, which is important when I'm interpreting the results. So first, we're going to visualize the data. It's always important to look at your data to make sure that the analysis approach you're taking is actually appropriate for the data that you have. So I'm going to use this new procedure called proc-sgplot, which hosts a suite of different plotting options to visualize your data. So I'm going to create a scatter plot here. I'm then going to create some histograms, but you can make a whole variety of plots like paneled figures, a variety of different bar chart types, heat maps, etc. There's a lot of plotting options. If you are If you are an R user, it might not look as beautiful as R, and I would agree. But this is great if you're just diagnosing what data you have and what you're working with, maybe not necessarily to put in a manuscript. I'm just going to comment something out so we can make some comparisons. But I'm going to make a scatter plot of the x-axis being the variable height, and then the y-axis variable being weight. So let's see what this looks like. Great. So just as I defined, I have height on the x-axis and weight on the y-axis, and each one of these dots or markers is an observation from the data set. So there's 19 dots to represent the 19 kids that were in this class data set. And so one of the kids has a height around maybe 51 and a weight under 60. And so we might look at this and say, what is the general trend that we're seeing? And I would say, well, it looks like if I were trying to fit a line through this data as best as possible, it would probably be a line going at an angle up. So some sort of positive relationship between height and weight. But let's actually look at the data a little bit more before I'm making these decisions. So let's look at the distribution of height first. So I'm going to use the SG-plot procedure again. And now instead of saying the scatter plot, I'm choosing the histogram option, and I'm going to choose height for my variable. So this is now a histogram, and it's not as nicely normally distributed as we saw with our data set that had 50,000 observations in it, but I wouldn't expect a perfectly smooth bell curve when we only have 19 individuals. So I'm not super alarmed by this. We see the bulk of the observations somewhere in the middle and then some little tails here. So that's generally representative of a bell curve. And then let's do the same thing with the weight variable. Again, I wouldn't say this is the most beautiful bell curve, but I'm not getting any alarm that it's extremely right-tailed, where most of our observations would be up here, and then it tapers off quickly and goes out far to the right. So I feel pretty good about how this data is looking to be able to fit a simple linear regression. Before I dive into the linear regression, I also wanted to provide the code to do a correlation matrix. Just sometimes this is helpful for various research questions. So this is a new procedure in SAS called proc-core for correlation. And then you can only run this on continuous numeric data. And so we have that var statement, as we've seen time and time again today. And so we would look at the correlation between height and weight. And so if I run that, I'll get my matrix where I have my simple statistics for each of those variables across the entire population. And then I have my Pearson correlation coefficient table that is showing the correlation between variables. So you will have if let's say you include 18 numeric variables that you're looking at the correlation of, you would then have 18 across in the table and 18 down. And there's always going to be a cell where you have the same variable being compared to itself. And so the correlation is 1. They're the same. So you expect that. And then you're going to have the correlation next between weight and the next numeric variable. And we can see here that these are significantly correlated. So you have the value of the correlation and then the statistical probability result. So your p-value here underneath. And so that would be for every variable that you are including in your correlation matrix. So that was an aside, but I just wanted to show you that code. So now let's actually fit our linear regression. So we're using our final proc today called proc reg for regression. And I will note that there are only a handful of procedures in SAS that require you to use a quit statement rather than a run statement. And proc reg is one of those. If you don't specify the quit statement, you'll see that SAS is still trying to run this procedure after you've submitted the code and moved on to other code because it needs the quit to actually fully stop running anything in the background. So it might not be a problem for small data problems, but if you have a huge data set that's really complicated, this could cause memory and crashing problems. So just to avoid that, make sure you don't forget quit with proc reg. But here we're going to tell SAS what our model is that we want to fit on the data. So we have a model statement, and then similar to R or other programming languages, you're going to have your Y variable or the dependent variable, and then equals to your independent variable. So this would be akin to the tilde in R. Or if you were writing out your regression equation, you would write your outcome equals and then all of the covariates that you're including in your model. So here we're fitting a model of height with the outcome of weight. So I will run that, and then we'll look at our results. So we first get output of the data, kind of like the metadata for our model. I will point out this number of observations read, and this is really important when you have missing data, because this will be the total number of observations in your data set, which we had 19 kids, so we had a total of 19. But let's say 12 of them didn't have a height value. This number of observations used would then drop down to 7. And so when you have missing data, then it causes a whole host of problems and you can't make certain assumptions anymore. So you really need to be aware of what kind of dropout you're seeing in fitting your model. It's called a complete case analysis. So for any variable you're specifying in your model statement, if a record or observation has a missing value for one of them, they will be completely excluded from your data that the model's being fit to. So just be aware. Then we have our analysis of variance table. These statistics may be useful to you at this stage in your career. We have an overall F-test of our model, so the test statistic and the p-value from that test. And then we have the parameter estimates table, which is what you would be reading in a manuscript. So the parameter estimate is the beta coefficient or the value that you're usually interpreting in relation to what your overall research question is. We have the intercept value. So basically, here it might not make sense, but for someone with a height of 0, then they would have an expected average height of negative 143. Obviously, that doesn't make sense in this context, but sometimes it does, depending on what variables you have. But really what we're interested in is our interpretation for height. So we see here a value of 3.9 about, and so we would interpret this as for every 1 unit increase in height, we see an average increase in weight of 3.8 or 3.9 pounds. And so that is this interpretation of interest with the simple linear regression. And then we have our statistic value and then the probability or p-value. And so we would say here that there is a statistically significant relationship for the 3.9 increase in weight for every 1 unit increase in height. And finally, we get a bunch of diagnostic figures. And so when I am fitting models, this is really important to look at. Are you meeting the assumptions for your simple linear regression or your multiple linear regression? I can't go into all of that today, but this is something that if you look at the SAS documentation, it will explain what each of these plots is and what you should be looking out for. That would be alarming to say, I can't fit the simple linear regression. Plots of the residuals, and then again, the scatter plot, but now you have overlaid your regression line and some bounds. So I just want to make the final announcement that Samantha has put in the chat the survey link for attending today, which will be your entry into the raffle, as well as your feedback being used for CU Data Week next year. If there's new topics that you would really like to see, definitely put that in the survey so that we can make sure we can offer that for you. And with that, I would like to open it up for questions. As you may be ruminating, I did want to say that I have annotated the code a bit today. So I want to let you know that I will add this SAS program to the OneDrive folder. So you have the very raw version that was already uploaded before today's session, as well as this one that has some new options and explanations. Are there any questions? All right. Well, if there are no questions, thank you so much for your comments in the chat. I do want to just share my contact information. And CETA's contact information. If you need statistical support in your own research, definitely reach out to our admin team. Our website has a bunch of free learning materials under the Learning tab, and that is also where the recordings of all of the sessions this week will be uploaded. So hopefully by next week, all of those will be added to our YouTube account, and then the links will be on our website. And thank you so much for joining us today. I hope you enjoyed learning about SAS as much as I love using it.